Okay, now we're going to talk about climate. So where have we got to on climate? We were going through those notes, right? More or less. This stuff, right? And you were all here, weren't you, last time on this? Yeah. Do you remember where we got to?
Didn't cover like all of it, maybe.
We might have done like super. What do you call it? Översiktligt. Very, very quickly. But didn't we basically just talk about first best? Or did we?
I think so. Maybe.
So why do we put it another way? What do we know so far? Tell me what you know about climate policy. So what do we know about first best climate policy, for instance? Fredrik, you look like you've got something to say.
No, it was just thinking about what did we talk. We started with the Golomsov model and discussed this.
Right, yeah, so we talked about integrated assessment models, which are used. If you're going to say one thing that many integrated assessment models are focused on, what is that in terms of the goal of it? Golomsov is one of them. What's it for?
Pricing carbon.
Right, finding what was generally called the social cost of carbon, pricing carbon. And how do they do it? That's the easy bit, once you've got that straight, okay, most of these models, they're about finding a price for carbon, and then you need the damage side, and typically you're going to need the sort of abatement cost side as well. There's actually one circumstance when you don't really need to know anything about abatement costs to price carbon. What is that? So this is quite important, actually. When do you not need to know? If you think about this, our original picture, draw it over here and it might even show up on the video. I think the videos end up wider than what I see on the camera. Okay, so what are the units on this? The first lecture, yeah. Sounded like you had.
Dollars per year and emissions in tons per year.
Yeah, or whatever. Something per year, emissions. So, and what's the social cost of carbon on this? So this is something about damage, isn't it? Or like costs. And this is, in fact, yeah, we can call this costs of emitting carbon. Dollars per year, and this is benefits. Where the benefits is like, thanks to, you can think of having different restrictions on total emissions. And given that restriction, what benefits can we get out of the sector or out of the economy? And as the restriction is relaxed, we can get more and more consumer and produce a surplus, right? And then beyond some point, it's not going to be binding anymore, is it? If the restriction is out here, how much are you actually going to emit? Are you going to emit this much? No. How much are you going to emit? So if you've got a free market, except there's a restriction that says, like a permit market or something that says you can't emit more than this in total, how much will actually get emitted?
When you cross costs and benefits.
No.
Oh, at the top.
At the top, yeah. Because it's not.
Yeah, the maximum.
It's going to be this much, isn't it? Yeah. So you're looking at this crossing point idea. Then you're thinking. Then this would be like marginal. This would be the standard economic diagram with price, dollars per ton, and quantity. Yeah. Then you're looking for crossing points the whole time. But here, this is a quantity of dollars, not a margin. So this is the height of this is the total surplus. And the height of this one is the total cost, so we're trying to maximize the gap. But if it's laissez-faire, then these costs aren't borne by the firms. All they've got to do is satisfy this restriction on emissions. And they'll do that. Then they're going to choose this point. Yeah. Okay. But if you've got a Pigovian tax, where are we going to end up? It's like a bit to the left, isn't it, where slopes are the same. Because the slope, that's where the gap is maximized, isn't it? So if this is the case, then we do need to know this curve to find the right slope. Sorry, we need to know, if this is the damage curve, we need to know the benefit curve. We need to know about abatement costs to find the social cost of carbon. Because if abatement costs had been like this instead, then the optimal point would have been here, and the slope is lower, the social cost of carbon is lower, right? So depending on how abatement costs look, the social cost of carbon is going to vary, given this curve. So what would this curve need to look like to make it enough to know the social cost of carbon? Chat to your neighbour or have a think about it, have a discussion. Or
the question was how the cost curve needs to look so that we know how, I don't remember.
we can straight away say what the social cost of carbon is without knowing anything about how this curve. Yeah. So if this is a straight line, then we just read then whatever the shape of this, at the optimum, it's always going to have this slope, isn't it? And the slope is the social cost of carbon. And what does this straight line mean? How can we put that into words that make sense? Not to a layman, but to an an interested, non-expert economist. Or even to a layman, what does that mean, that is straight line?
For every ton of it, the total cost increases the same amount?
Right, exactly, very good, yeah. And the more economic way would be like the marginal damage costs are constant. Yeah. Very good. So if that's the case, the only thing we really need to get the social cost of carbon is the damage function. But if it's curved, then we need to sort of solve the whole model to know what the right Pigovian tax is. And it turns out, so, what's the guy's name? Nordhaus, the Nobel Prize guy. And Hassler and Crucell, Golosov, Hassler, Crucell. There's a fourth author, isn't there? Can't remember who the other author is. Whatever, maybe it's only those three. They just follow Nordhaus actually on the damage side. What does Nordhaus assume about damages? Is it like this? Well, yeah, they modified Nordhaus slightly. But broadly, are the Nordhaus damages kind of like this, or are they like this? Or this is super important actually in terms of understanding the Nordhaus model and the implications. I probably didn't emphasize it enough in the videos. I certainly said something about it. I hope, or whatever. Do you know? You don't know? No. Really? No. So, let's have a look. Let's see if we can find it. Okay. Okay, fine. Somewhere we're going to find some equations. See, part of what I'm trying to do in the course is to actually get you thinking like a researcher in a way, which is partly why I'm doing these kind of things. Yeah, that you don't just have to look at textbooks to find things out. And it's not because I'm thinking you're all going to become doctoral students, but whatever you're doing, whether you're working for a government authority or whatever, you need to be able to actually get to the bottom of stuff. Or to, investigate things yourselves. So we skipped the definitions, which makes it tricky. So this looks like damages, doesn't it? So damages is gross production times the fraction that you lose here. Do you remember when we talked about that? You knock off a fraction of what you would otherwise have produced, a sort of percentage. So that's why damages go up with GDP. So abatement costs we're not interested in. So what's this DAMFRAC? Yeah, here's DAMFRAC. Okay, yeah, so this isn't especially transparent actually, is it? Because what we've got something, this is a fixed parameter, isn't it? Because it's got not got a t on it, so that's just a number times something, a t, and then another parameter times something to the power of something else. And TATM, we don't really know. Yeah. Okay, no, it's not transparent. So that didn't help us. So we have to have a look at Golosov instead. Okay, let's see what they have here. Okay. Second, we specialize our damage function. we follow Nordhaus and assume that damages are multiplicative. So it's baseline production times 1 minus T. So you're losing a percentage of the baseline. Okay. So that's fine so far. Then we've got this. 1 minus D is e to the minus gamma s minus x bar. Okay. So I don't know if this is their notation, but I'm just making up some notation here. So y star try and find a pen that works. So y star is what you finally end up net production. I've just made that up, okay, and it's y bar times 1 minus d, which is y bar times e to the minus gamma, blah, blah, blah. Okay. So you might think, well, this is a bit tricky. I mean, it's not nearly as complicated as Nordhaus's, but like, how do we get our heads around this? Well, why don't we just look at the y star ds, because S is the stock, the atmospheric stock. Okay. So help me, what's the y star by the S? Have a think. Check with your neighbour. Do it, everybody. Meanwhile, I'll try and find a better pen. Oh, got one. Okay. You're still. No, he's still in the starting blocks. They start through far. You got nothing. So what have we got? Gamma minus D. So you can actually write it as minus gamma y star.
Yeah.
Yeah. Is that gamma? Yeah. So basically, you're differentiating the exponential.
Yeah.
So the differential, if you've got y is e to the x, what's dy dx?
Is that why?
Y is e to the x. Dy dx is just.
Yeah. What's the power to add c? Oh.
That's
Okay. X.
X.
Yeah. So x.
So it's just e to the x. You
Ah,
get,
yes,
you get it back,
yeah.
yeah. It's just y.
Yeah.
And if y was e to the 2x, it would be 2e to the x.
Yeah.
Okay, so we're just going to apply that here. And this we can think of as y bar e to the plus gamma s bar, and then times e to the minus gamma s. Okay. If you think about how power rules work, you can split this up. So this is just the constant, and then times this. So then when you differentiate this, it's just minus gamma times what you started with. So, and what you started with is called y star, so we can actually just write like that. So what are the marginal damages? They're a constant times your original GDP. Okay. Which is, yeah, I kind of lost track of where we were. Which is where we were like a while ago, isn't it? Here. It's basically this. then I've oversimplified slightly because to get the full marginal damages of emissions, I've been pretending it's a flow pollutant. You also need to think, oh, this stuff is going to kick around for ages, so to get the net present value of damages, we need to think about all the damages caused over the whole period. So then we need to allow for decay, we need to allow for discounting, and so on. But given the relatively simple assumptions these guys make about decay and discounting, and possibly something else might be relevant, basically decay and discounting, you end up with the conclusion holds even in the full dynamic setup. That the marginal damages are just proportional to today's production. Actually, yeah, that's also assuming decay, discounting, and the growth rate of this. If they're all kind of linear, then this still holds. Although it's not gamma anymore, it's gamma times a bunch of other stuff, which is linked to the decay rate, the discount rate, and the growth rate. Okay. So if we know in this model, and more or less in Nordhaus is more complicated, but in the end, it kind of, the sort of Nordhaus damage function is kind of like this, if you like. Not really, but kind of. When you just actually put the parameters in, it ends up like more or less a straight line. So it turns out we don't even really need to know anything about abatement costs to work out the social cost of carbon. We only need the damage function, which is linked to the sort of short-run damages, and then also discount rate, growth rate, decay rate. Okay. We'll take a break very soon. But I just want to round this off, so we're just like, where were we? So if you believe this damage function, where does that leave the criticism from people like Pindyck and Weizmann? What was Pindyck's big criticism, or his biggest criticism? Pindyck was the guy who was saying, this is all bullshit. Kind of.
Is this catastrophic scenario?
Right. The flat tail thing was his biggest, he had a lot of criticisms, but his biggest one was like, what if there's fat tails? But basically, if this is the cost function, then there aren't really ever going to be any fat tails, kind of. Because you have to be like for damages to get really, really serious, it's like, you basically need emissions, to be way, way out. Otherwise it's like, no, you're never going to get catastrophe. Whereas if you've got a model that says like damages are like this, then you could say, oh, it's fine because we're only going to, let me actually read it. Let me say, if you had a model that says damages are like this, okay. Then if you're totally certain about that, you could say, okay, fine, we'll emit this much. But then if you start saying, well, actually, we're not quite sure where this thing happens, that's going to change things, right? So this is Pindyck's point. But if we're totally confident that damages are like this, and sure they might be like this and they might be like this, it's not that big a deal. Yeah. And this is kind of Nordhaus's whole analysis. He doesn't really seem looking at what he's writing and so on, he's probably written explicitly about it, but I haven't read that stuff. But just from the way he sets out the dice model and so on, it's like, yeah, we don't know exactly the slope, but okay. So, where were we? Yeah, it's like what do we know so far? We've got these IAMs which give us an estimate of the social cost of carbon, which makes a lot of sense as long as we don't think that the damage curve is going way off at some point anywhere near where our optimum is. Because if it is, then we really, really need to take any uncertainty about that and uncertainty about emission scenarios and climate scenarios into account in a big way, and that's going to change things massively. But even on these kinds of estimates, without that, what do we sort of do in first best? Well, within within 40 odd years or so, depending on the slope and depending on what you think about this, you're going to be phasing out coal. Yeah? You're going to be leaving coal in the ground. And then it's a no-brainer kind of to stop the sort of crazy deforestation. The benefits of which, on this curve, so to speak, you're getting almost nothing, no economic benefits out of doing that deforestation. Or, minimal. Of course, people who are doing it driven by economic incentives, but the payoff is very small. Okay, let's stop there, and then after the break we'll start treading sort of new ground. But this is super important what we've just been through, so to have that fundamental, solid base. Okay, how long should we break for? Should we do the usual, 15 minutes? Yeah? So, what do we know about first best? If we believe Nordhaus, it's kind of we don't need to know too much about abatement costs and so on to know the social cost of carbon. And we don't need to worry too much about catastrophic outcomes and so on. At least if you believe DICE. I'm not sure what Nordhaus says explicitly about catastrophic outcomes. But if you believe people like Weizmann and Pindyck, we need to really worry about if this curve might stick up very steeply, and in that case, at what point, and how certain are we? And then we also need to know anything about then the best policy. We need to know a lot about how we think firms are going to react to our abatement policies. Okay. Then in terms of assuming some social cost of carbon, what would the planner actually choose to do? And the biggest thing is going to be to gradually or pretty rapidly get rid of coal. Okay, that's like priority number one. Another important priority is to stop deforestation, but that's not nearly as big an issue as stopping coal. And then once you stop coal and stop deforestation, then later on we want to stop oil and gas use and deal with other issues like, I guess, concrete or cement and steel making and things, and air travel, the really tough ones. And of course, something we haven't mentioned at all, but if you assume those ones are totally intractable, but you still want to get net emissions down, sort of more than that, so to speak, what can we do? Something we haven't really could tolerate some emission, some sectors emitting sort of way too much, so to speak, if there's other sectors with either zero emissions or potentially even negative emissions. So like reforestation and so on. And then there's also the kind of almost taboo in many circles is the sort of geoengineering idea, right? Have you heard of geoengineering? So Johanna has, you guys.
Like, I don't know, like some chemical or physical reactions to get carbon out of the atmosphere?
So that I'm not sure if there's total agreement about what's meant by geoengineering. So there are ideas to sort of pull carbon out of the atmosphere in different ways, and I suspect it's a grey area whether you call those geoengineering or not. Like there's one idea which is to have a lot of biofuels, grow forest, and then put it into power stations, and then have carbon capture on the power station and store the carbon. So then you have negative emissions and energy production at the same time. Some people might call that geoengineering. I don't think that's really what most people think of with geoengineering. The main thing people think of is that you're mucking around with stuff that means that the climate doesn't warm up even though you have carbon in the atmosphere. And there's at least one method that we know would work and is not particularly expensive. Okay. None of you have any idea what I'm talking about, or maybe? It's basically simulating volcanic eruptions by spreading sulfur particles. I can't remember exactly what kind of sulfur. Is it like iron sulfide or something? I can't remember exactly. But small particles in the upper atmosphere, which happens when you get volcanic eruptions, and we can measure the effect on temperature. You know, with the big eruptions, you can see that global temperatures go down a couple of years after. So then basically we would need to be sticking these iron filings or whatever they are in the atmosphere every couple of years out of the back of planes at high altitude. And of course that raises a huge number of other questions. I mean, for one thing, it doesn't return the climate to what it would have been. It cools the climate, but it's also going to affect regional patterns and not going to go back to what they would have been. It raises a lot of questions.
Wasn't also sulfur responsible for sour rain? Or was it
For acidification, yeah. I think the quantities, I'm not sure that it would lead to acidification or acid deposition, acid rain or so on. I don't know, actually. I'm not that up on geoengineering. Yeah, could be one to, I was thinking of the project, could be one to look at in terms of the project. Okay, let's just have a quick look at this EPA page, which is here just to get, you've probably seen this kind of thing, just to give you an idea. It's like, what's the scale of these different types of emissions? So it's pretty significant, the emissions, sort of non-industrial emissions, partly CO2 from things like forestry and also methane, nitrous oxide. Some of these are also from industrial, but the majority is not. Yeah, it's from land use and cows and whatever. Okay. But so you might think like, why doesn't this stuff play a bigger role in the debate? Well, one reason is linked to this, which is the Griscom paper that I've got in the notes. Oops. That. When you look at that figure here, it's like the fossil is growing, whereas so what's this NCS? Natural climate solutions, yeah. The potential for them is basically limited. So, like, okay, we stop deforestation, fine. And we're kind of working on that. But then once you've stopped it, okay, well, we could reforest. And that's helpful too, but given that we want to feed the world and we want to feed the global population, etc., it's important, but this is more important. And when you think in the long run, dynamic perspective, then this part is even more dominant than this part. Yeah. Because at least this is hopefully shrinking over time anyway, whereas this is growing. This one is kind of interesting though. If you think of beef production is growing rapidly, so and that's of course partly why that is growing on the agenda, so to speak, moving up the agenda and discussed more and more. Okay. So that's a bit of the first best. There's a super interesting discussion about land sparing. So I'll just mention what that is. So what would you do? How would you manage the surface area of the Earth in first best? That is very crucial aspects of that are very open questions. So sure, we want to stop deforestation and reforest in many areas where you're hardly getting anything out of the land, but the forests could really give something. But then, how should we deal with agricultural land? So some people would say, oh, we need more organic agriculture with less inputs, which we need. It takes fossil fuels to make these nitrogen fertilizers, and it's leaking into the sea, into the oceans, which is causing eutrophication, and blah, 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 and killing bees and so on. But then other people would say, look, per hectare, you're getting much less production from organic agriculture than from conventional. And actually, we should be trying to maximize production from the hectares we've got under agriculture and plant forest on the rest, kind of, if you like, or let. So instead of having a lot of agricultural land that's kind of producing food but also good for nature, that's the sharing idea. But there's a sparing idea that says we have much less agricultural land, which is kind of a desert in terms of nature, but with producing food at an incredible rate. And then the land that we spare can be full-on nature, full-on plus event may be carbon sequestration. So that's the sparing idea. So this is a really, really important debate, and it's not clear kind of what the optimum is. Yeah, and even if the social planner knew what the optimum was, there's like huge issues about, okay, how would you, through regulation, achieve this? So maybe this is a question for Friedrich, but what kind of agricultural land is, if we define agricultural land broadly, what is the least productive in terms of calories per hectare? A
With
huge,
respect to like soil quality, or how do you?
for a given per hectare kind of.
Um,
So what land, if you're trying to capture carbon and make food, and you're going for an intensive kind of strategy, what land would you want to turn over to nature? It's a
difficult to
huge
say.
category of land.
I don't know if I get the question right, but I think the most useful criteria would be like to have the lower grade soil quality that is then ruled out with in tropical areas or something where soil is really not fertile. It
Yeah.
doesn't make sense to grow something on there.
Right.
So, but I think I wouldn't be able to single out like these types
Yeah.
of land.
No, I totally agree. So where there's low soil quality, definitely, and typically one huge issue is like marginal grazing land. It's like where you've got huge areas that could be forest, but instead you've cleared the forest and you've got grazing animals, and the productivity per hectare is incredibly low.
There's also, not from a carbon perspective maybe, but when you wouldn't have like some cattle to graze something on some area, over the decades it will be a forest again. So then it would take up more
Yeah.
carbon, but at the same time the biodiversity
Yeah.
reduces it.
So this is where you guys can kick in, right? What are we talking about now from a Swedish perspective? In a one word, what kind of land, what do we call these? Marginal grazing land. What's that called in Swedish? Aye? Not these marginal ones. Something very dear to the Swedes. Aye? I'm thinking like hagmarker. High, it's these traditional grazing lands. They're not ploughed at all, unimproved, marginal grazing land with like juniper bushes dotted around and things. And this is like, we have to have our hagmarker, and the biologists say, look at this, whatever it is, there's all these rare flowers and whatever. And this is, from a carbon perspective, it's like, they're a disaster. Okay. Because you're hardly getting any production out. You could have forest there instead. And there's another issue. So what's grazing these lands mostly? What animal?
Some sort of ruminants or cattle that emit methane.
Typically it'll be beef cattle, yeah. And so they're emitting methane. And they're growing very slowly. So the emissions per steak, so to speak, are massive. It's like, don't tell LRF, they won't be happy. You know what LRF is? Swedish farmers organization.
Lantmännens, or what is it?
Lantbrukarnas riksförbund.
Okay, but they're different from this. Isn't it something like Lantmännen?
Lantmännen is like it's probably run by LRF, I don't know. Does anyone
It's
know?
more of a union.
Is Lantmännen a union? Right, yeah, I don't know. Yeah. Okay, this is a really hot topic. Okay, in Sweden, kind of this sort of emissions from meat and clashing with the farmers that are upset, and then you've got the biodiversity aspect, and it's like tricky stuff. Okay. So, if we're then thinking, imagine we've got an idea what we want to do in First Best. We've sort of parked the whole agricultural dilemmas where we really don't know quite what to do. Like, if you could forget about biodiversity, you would go for sparing. Sure, you'd go for, as I see it, high intensity on small areas and like plant forest on the rest. But then there's open landscape in Sweden and there's biodiversity, etc. But if you're then thinking about what other aspects do we need to take into account when we're thinking about trying to implement First Best? What's stopping us from just going in with a Pigovian tax, if you like? And one of them is market power in the fossil fuel sector. Okay. And this is like massively under-researched for various reasons. Partly because it's just so tricky. So you've seen this cartoon, but you guys, if you've read any Swedish joke books, you would know, like, this is supposed to be some lamp, and it's casting light here. There's a Norwegian guy looking for his keys. Yeah? Maybe it's a more modern joke. It's in all my daughter's joke books. The Swede comes along, or her old one, she's 13 now. But the Swede comes along and says, "What are you up to?" And the Norwegian says, "I'm looking for my keys." "Oh, where did you drop them?" And he said, "Oh, over there." And the Swede, "Well, why are you looking here?" "Well, it's dark over there, I'll never find them," kind of thing.
In the other course, you never gave the context with the Norwegians and the Swedes.
Okay.
Like, okay, refer to research areas and just having your...
Yeah. Maybe we had a Norwegian in the class, I can't remember. I don't think so. So the point is, economists are a bit like this, right? It's like, we know there's market power in the fossil fuel sector, but that's like really tricky to model, so let's build models without any market power in the fuel sector and try to understand the oil market without including market power. It's like, or try to understand the effect of climate policy on oil extraction in models without any market power. And there's like hundreds of papers on this stuff, and there's like 2 with market power. So I don't know if, and these ones, it's like this green paradox stuff. Anyone heard of the green paradox? Just as well, or maybe you have.
I can't remember it.
No. So the idea is that, like, basically the price of oil is pure scarcity rent. And so if you then threaten, if you say, look, we're going to tax the oil, or we're going to bring in renewables and subsidize them, you would just you're cutting into the scarcity rent, and the oil will still dominate, kind of. But actually, the price of oil is mostly market power becomes, it's like a monopoly rent, if you like. Some of the same conclusions still apply, but not all of them, and some of them, there's crucial differences. Okay. The biggest problem with, so generally you might think, okay, OPEC has a monopoly, they drive up the oil price, that cuts oil consumption, that should be good, right? If we want to bring oil consumption down, what's the downside of that? I talked about it, pretty sure.
But we,
Yeah, no.
It looked like you were about to say something or not.
I'm not sure that I remember correctly, but they would use other kind of oil that's harder to get.
Right. And that might, in the first best, we might have left it in the ground.
Yeah.
Whereas in first best, probably we're going to use all the Saudi oil. And that's depending on what you think about Weitzman and fat tails and things. So what you could end up with is that now we use this Albertan stuff, which has higher emissions, and then later on, when we should be using nothing, we've still got a bunch of Saudi oil. And then at that point, it's because the Saudi oil is still so cheap, it might, from that point looking forwards, this is still first best to use the Saudi oil. So you end up with higher emissions in the long run. You end up using them both. Whereas if you'd use the Saudi oil, and then it was like, further in the future, should we use this Albertan oil? No way. Because of the link between GDP and the damages that we had over there, yeah. So the damage cost goes up all the time as we get richer. Okay. So this is a big issue. Then there's knowledge spillovers. So what's the issue with knowledge spillovers? What have we said about that? I think I just said some stuff very briefly, didn't I? Does anyone remember?
It's considered as a positive externality, so you also cannot really put a price on it, and once someone came up with an idea, everyone can use it, which, I don't know, the consequence takes away the incentive to do more research on it, because you cannot get the whole benefit out of it, or?
Right.
More like you don't allocate enough resources that are like efficient for knowledge.
Right. Yeah. That's
Because, yeah.
good. So I have an incentive. What's my incentive to do research? It's like, okay, if I do research, I'm what do you call it? VD, like VD, like managing director of BMW or something. And it's like, okay, we have to do research. Why?
Then we do research for you, but also the spillover effects will help like more people.
Yeah, okay, yeah. So let's just do one thing at a time. But yeah, so why am I doing, just say again, like why do I choose to do research in BMW?
To get money, I don't know.
Yeah, but like if I didn't do any research, what would happen?
nothing.
I mean, in the short run, it would be great, right? You'd save a load of money, but then in 10 years down the line, you'd be out of business, right? And this is basically why the small car manufacturers like Saab and so on can't survive. Because they can't do enough research. Because it's a scale thing, yeah. The biggest scale advantage, I'm not an expert in the car industry, so I'm kind of guessing here really, but it seems to me the biggest scale advantage is on the research costs. How can you keep up, you know? You need to defray your research costs or spread them out over a huge production. So yeah, you're going to go out of business if you don't do research, because you're not going to keep on. But then what are the benefits? And of course, people who buy BMWs benefit from that, as well as BMW benefiting. But tell us then, what more benefits are there from the research that's done in BMW? You kind of already said it, but...
Yeah, well, other car brands would probably use the same techniques after a while. And
Exactly, after a while. So within the 10-year period, I can like do the research and put it in, and like, and maybe I'll come up with some really great new idea. Then what's going to happen, the other car manufacturers are going to look at that and think, oh, no, what a disaster. BMW have got I can't find the word, they've got ahead of us anyway on this. And so that will be a competitive advantage for BMW for the next 1, 2, 5, 10 years. But then at some point, depending on patent laws and whatever, the other manufacturers are going to incorporate that into their designs. Could be because the patent ran out. It could be because you don't even take out a patent, but you just rely on secrecy to give you at least a few years of full advantage compared to everyone else. It could be that the patent's still in force, but other people have still seen what you've done and developed it further, which then gets around the patent. Okay, so what you typically, or a common metaphor in economics is you say that other people are standing on BMW's shoulders. So it's kind of, BMW still has research incentives, but they're not getting the full social payoff of their research. So if I make a pizza and sell it, in theory, the difference between the price that I sell it for and the cost that it took me to make it, that is kind of the social benefit of the pizza, so I get the full social benefit of my work. Do you see what I mean? So a typical good, it's like there's no real externalities or they're trivial. But when I do research, I get some benefit, but society gets lots of other benefits that I never get. Okay. So, given that this is the case, what should Stefan do? The regulator. Subsidize?
Research.
Right. So, is that it? Is that sorted then?
Well, I think of your paper that you published, so maybe you want to steer the research in a direction towards what's also beneficial for society in terms of emissions.
Right. But if we just park that for now and just think that Stefan sees this positive externality and he thinks, well, we'll just subsidize researchers for some proportion of their costs and we'll get some economists to work out the right proportion and then everything will be fine. We just park the whole direction thing for a while. Does that work? Is that like no problem? It's obviously a leading question. There is a problem. What's the problem with that? Remember I talked about the bridge before? So I've gone through this, but
Yeah.
like super
They
fast in
won't,
about
like,
2 minutes.
Work hard enough or get lazy or whatever, right? Or no, you couldn't really, about the bridge, they could like, oh.
It's kind of linked to what you just said.
Yeah,
but
they
it's-
don't build it, and then you cannot like hold them accountable, right?
Yeah. So if with a bridge, if Stefan orders a bridge, and then 10 years later there's no bridge, it's like, okay, we're going to take you to court, we want this 10 billion crowns back, etc. They'd probably start doing something a bit sooner than that if they saw no bridge was being built. But if the Swedish, and you could say if the Swedish EPA gives someone 3 million crowns to build a, what do you call them in English? En fisktrappa. I only learned that word since I came to Sweden. Do you know what it is?
No.
A kind of thing to help fish get past dams and things and weirs. A sort of fish staircase.
Yeah, okay, I know then the concept, but I also wouldn't know I wouldn't even know the German
No.
word for that.
So if the Swedish EPA, Naturvårdsverket, gives someone 3 million crowns to sort of build one of those and figure it on, then 3 years later they come back and say, oh, you know, where is it? But if they give me 3 million crowns to do research on sustainable consumption, which they have done, and then they give me another 3 million to do research on sustainable transport, and then it's like 3 years later they come back and they say, okay, like, where's the results? And I sort of say, yeah, well, we got this and this and this. And they'll say, but that's not what you promised in the application. And it's like, yeah, well, things didn't quite work out as we hoped, and it was really tricky, this and that. And of course, they could say, oh, yeah, next time I apply for money, then it might be, well, no, we're not going to give him any. He never comes up with anything any good. And I've actually heard that. Not about me yet, but about another researcher. It's like, oh, X never comes up with anything. It's really tricky. And imagine, and that's to an academic. But imagine Stefan is then paying like profit maximizing firms to do research. How tricky is that? Like, A, are they going to do it? And B, would they just have done it anyway? Is this really adding anything to what would have happened anyway? And C, kind of, there's also a risk that if you imagine you pay all the research costs, okay, so you pay the full costs of the firm's research, which is what is the norm in academia, but not for firms. In fact, even in academia, it's getting less and less like that. But why would you not pay the firm's full costs? So the model would be you invite applications from firms for ideas to do research, and you tell them more or less, you know, we want sort of sustainable transport research, and then we'll pay all your costs. What's the problem with that?
Well, we will just take the money. Or,
Yeah, but that's kind of always a problem in a way, isn't it? But yeah, it's kind of if there's no cost in it for them at all, it's like they could come up with any wacky ideas and try, oh, this is going to be brilliant, you know. And then they don't really have the strong incentives to sort of control costs and make sure. It's like if you're saying, look, we'll pay 20%, and then you want to see accounts and so on that they're spending at 80. Then it's like, okay, they're not going to just apply willy-nilly for all sorts of wacky stuff. But the analysis, the second best economic analysis might be saying that ideally, actually, the external benefits are so great if you can make them focus the way they do when they're paying for it themselves, that really we want to be paying 75%. But if you offer 75%, it's just like, wow, let's do this and that. And so even when you're just trying to boost research in general, it's really tricky. So there are a sort of a mix of different policies to try to encourage research, but most economists would still say that research is like drastically undersupplied compared to what a social planner would do. But they're still not saying we should therefore subsidize it a lot more than we do. Some would say that, but others would say no, because there's all these. You're not going to get value for money that way. Okay. So then you might think, well, look, we just subsidize research at the 20% level. We've worked out that 20% subsidy research is about right, given these dilemmas and so on. And we can kind of forget, we park the research sector and then just go with Pigou. But actually it's more complicated than that. So now we're getting into this direction thing. So why, does anyone know, well, you've seen the video maybe. Why is it, what might it make it more complicated? It's like, if you think about standing on shoulders, yeah, so the biggest spillover from research that isn't captured is the standing on shoulders, that if I come up with something, other people are going to build on that. So, who is going to have most people standing on their shoulders? The sort of solar, the researcher who makes a breakthrough on solar PV technology, or the researcher who makes a breakthrough on efficient coal-fired power stations?
I think you had this picture in the videos too, right? Where then more people are in the coal sector, and therefore there's a higher incentive to be more efficient with coal than to do renewables, because you have then, I don't know, it's 4 times bigger, so you have 4 times the profit in the end or so.
Yeah. So, all else equal, you'd expect more people researching in coal than in solar, because coal is a bigger sector. All else equal. But who's going to have the most people standing on their shoulders? What do we expect to happen to these two sectors over time?
Over time, silver.
This one you'd expect to grow,
Yeah,
and this one we expect to shrink.
This term.
Yeah. So, if I discover a way of getting a little bit more energy out of each ton of coal, a little bit more electricity, that's kind of great. But in 40 years' time, who cares, you know? There's not going to be many people building on that and using it in the future. If it's of course it depends, if it's some fundamental breakthrough that can be used in other sectors. That's another big issue. You should subsidize sort of fundamental research more than very applied research. Again, because of this idea. But if we assume it's very applied to just coal-fired power stations, you're not going to have many people standing on your shoulders. But if you come up with some solar PV breakthrough, that's going to be built on, very much more likely to be. Yeah. So you're going to have a lot more people standing on your shoulder, which means you're going to capture a smaller proportion of the benefits, social benefits, compared to this guy, who captures a bigger proportion, because there's not, if we think of it as a shrinking sector, then there's not many people going to stand on this guy's shoulders. So then, there's actually less need for a research subsidy in this sector than in the average sector in the economy, if it's shrinking. Whereas in this growing sector, there's more need to subsidize. So if we decided in the average sector, if we decided, look, we'll give them 20% of their costs, then in this one you might give them 10%, and in this one you might give them 30%, just to illustrate the point. Because these other dilemmas still apply here, in terms of them just wasting the money and so on. So it's like, you're in second best, as soon as you've got knowledge spillovers. If you could just fix the knowledge spillover with a 75% subsidy, then you would just do that. And then what would you do with the tax? You would just go with Pigou. Because the thing is, this also has implications for the tax. So if this is true, what are the implications for taxation?
Well, it's gonna have to increase over time because more and more researchers can get the 30% in silver.
Aha, you're thinking we need to finance this.
Ah, yeah.
Yeah, I guess that's true, but the actual costs compared to financing the health service or whatever, it's not a big deal. But that's absolutely true. But I'm thinking about the Pigou, what level would you set the tax on emissions? So the point is, this second best thing, that they interact, Remember with the market power. If there's market power that is leading to less production, then it could be that we don't need to tax emissions, in theory, because they're already producing less because of the market power. So we need to take account of the one market failure when we think about policy to correct the other. So that's what I'm... So if we imagine imposing a tax on coal use, okay. In the simplest possible kind of model, you would basically say, look, we've got stuff, we're using coal to make electricity, the coal causes emissions, then there's other sectors in the economy. If we tax the coal, we'll raise the price of electricity and people will consume a bit less of that stuff. That's the simplest story about the effect of the tax, That you are then pricing the coal-based product, the price goes up and consumers consume a bit less of it. Okay. That is the simplest story. Then there's two other stories that are hugely, hugely important, often far more important than that first story. We'll take a 7-minute break and see if you can come up with the other two stories. Or we'll talk about it after the break. Okay. So what are the other two? Frederick looking miserable. Or pulling a face. You're not sure?
We talked about if the price of coal is going to be higher than some other energy might be extracted, that is not good for that.
Right. So in general, one of the other two is like you switch technology. So I tried to paint the first scenario very narrow. So we've just got this coal, we're making stuff using coal, then there's other stuff around. So we raise the price of the coal-based stuff, and so consumers are going to choose the other stuff. But generally, consumers are quite stubborn. Typically, like price elasticities of demand for stuff are not that high. So a much bigger effect is at the firm end, the firm's choice of technology, typically for many, many types of goods. So we raise the price because we price emissions, but actually the effect then is that firms switch technology. So it can be that they find ways of like making the stuff using a bit less coal by being more careful or whatever. But more radically, the big effects kick in when they just say, let's use gas instead, or let's use solar instead, or whatever. So it's like, what's the effect of the Pigovian tax? From this kind of story, if we know these curves, then we know sort of all we need to know, kind of. But it's still interesting, especially in second best, when it's more complicated. We want to know what's really going on to then be able to see the best policy. So apart from changing consumption patterns based on prices, we're also changing firms' choice of technology. That's a massive, massive effect of, say, a Pigovian tax. That's number two, but then what's the third one, which is also very important? It's kind of what we were talking about. Okay, we're changing what firms choose to do their research on. Okay, we want firms to do more research on getting the costs of the clean stuff down. I can't remember why I kind of brought that up. I kind of lost now where I was in the whole story. So we were talking about this. Yeah, it was like, okay, so what does Stefan do to the Pigovian tax? So Stefan knows, what is this Pigovian tax doing? It's raising prices to make consumers a bit less keen on this stuff, but it's also encouraging firms to shift technology, but it's also encouraging them to do more research on this the cleaner options. If most firms are currently here, one of the things the Pigovian tax will do is encourage firms to shift to here. Another thing it will do is encourage firms to do this research. And Stefan knows that this research is severely undersupplied, whereas this research is not nearly as severely undersupplied. So what might that lead Stefan to do? And he also knows it's really tricky to correct this undersupply. So what might he do with his emissions tax? Imagine that we're in the Nordhaus. Okay. And there's no uncertainty. Stefan knows exactly what the optimal tax should be. It should be this slope. But he's got this stuff going on too. What might he do with his tax? This is kind of what my paper's about, ultimately. Or it's not the only, it's part of what the paper's about. So he wants to encourage more research in this sector. If he could, he would just give them a great big subsidy, much bigger than this. But he knows then they would just waste it. So he gives them a bit more of a subsidy, but he knows that they're still going to do much less research than what he would really like to see being done. So how could he get more researchers into this sector?
Can you tax co-research?
because if you had a fixed number of researchers and they're just choosing between two sectors, that might work. But actually, and some models are built like that, the Acemoglu model is built like that. But in reality, you've got agents deciding what to do with their resources. So if you tax coal research, they're going to do something other than coal research, but they're not going to necessarily do more of this. So what were the three effects of an emissions tax? One, on the consumers. Two, on firms' choice of technology. Three, on their research effort. And then we're saying this research effort is severely undersupplied and it's kind of an intractable problem for Stefan. So what might he then choose to do with his emissions tax?
Not taxing them or not?
Because that will worsen the
Okay.
undersupply, won't it? So Stefan knows the Pigovian level. It's this slope, yeah. But he might deviate from that level anyway. That's the point. So he might tax more than the Pigovian level.
For both sectors? I mean, should it just be for coal?
He'll tax emissions, yeah.
Okay.
So the tax is on emissions. But there's no emissions from this sector.
Okay.
So if you tax, and most firms are still using this technology. Yeah. If you tax this, like in first best, you would tax it at Pigou, right? But in second best, where you've got these intractable research knowledge spillovers, you really want to encourage more people into this research sector. So imagine you have more, forget Pigou and just imagine different levels of taxes on coal power. What's going to happen to the number of researchers here as a function of the level of the tax here? It's going to increase, yeah. The higher the tax here, the more people are going to start doing research here. Because it's like, oh God, this coal is ridiculously expensive. This is even more expensive, but there's opportunities to bring it down. We've really got to get going on this, because he's just taxing us to death here, and it's going to go up in the future too. So that could be a reason to tax even higher than the Pigouvian tax, yeah. To actually, so the short run cost of that would be that you're kind of punishing these guys more than they deserve, so to speak. But the benefit is that you're encouraging more research here, and in the long run you will reap the benefit. Yeah. So that's an advantage. That's a kind of example of policy in second best. Yeah. So remember the monopoly example. It was like, oh, if there's monopoly, it could be that you tax less than Pigou, because the monopoly is sort of doing some of your job for you. Yeah? But here, for a completely different and more subtle reason, you might end up taxing more than Pigou to try to solve your other externality at the same time as you more or less solve the emissions externality. You actually sort of go too far on the emissions to try to solve this other stuff at the same time, or get. The Pigovian tax is helping to solve this, of course, but you might push it even further because this problem is tricky. Okay. And that is kind of my paper that's just published. There's the paper that is to some extent responding to is this paper from 2012, where there's no proper welfare analysis in that paper, but there they assume you've got a fixed number of researchers and they're choosing either between this sector or this sector. And there's no problem at all with fund subsidizing research. And basically, essentially in first best, you want all the researchers in this sector and none in this sector. And so you just subsidize the hell out of them until they all switch. That's the 2012 paper. So that's much simpler, kind of. Okay. Let's see where we're getting to. Okay, so I'm trying to think. So we've talked in depth. I'm looking at these 5 points. We've talked in depth about number 2. Sorry, I kind of kommit av mig lite, som ni märker. I kind of got a bit lost here in what I really want to do with this 32 minutes left. Okay, why don't we just take this regulatory instruments? Okay, so in theory, we just want to fix all market failures and get first best. So we need carbon pricing, we need research subsidies, we need to price methane from cows, we need to price nitrous oxide from soil, etc. We need to correct market power in the fossil fuel sector. We could break up the monopolies or something, or have other methods to correct for that, etc. And if we could do that costlessly, without any transaction costs and without any spending any money on inspectors and regulators and stuff, that would be first best, and everyone would be as happy as they possibly could be. But there would still be winners and losers from that, wouldn't there? So to make sure everyone agreed, we'd either have to force the losers to accept the deal, or we'd have to compensate them. So how are we going to achieve all of that stuff? Well, we can't, obviously. This is second best. It's about compromise and finding the least bad solution and so on. Okay. And I just took you through some of this stuff linked to the knowledge externality. But let's now have a look at the problem linked to like free riding. Okay. So you know what I mean by free riding, right? This is yeah. So in environmental economics generally, in the sort of first year stuff, it's like, okay, there's a bunch of people emitting, there's this external effect, we just put a tax on. But then what if you've got different countries? Yeah. So this is a massive problem, obviously, in climate change, because the pollutant is uniformly mixing, right? So what do we try to do in climate policy, in practice? What are people who care about climate change, what do they try to do to get round or to solve this problem of with different countries and countries free riding and so on? They're trying to get people to agree, aren't they, and to sign agreements. You could say, often in the literature, you frame it in terms of building coalitions. Okay, the literature is often about building coalitions. And you want your coalition, everything else equal, you want it to be as big as possible. You want as many countries as possible to sign up to it. But you also want the coalition policies to be as close to first best as possible. And that can be a dilemma, right? That you could get everybody to sign up to something that said, oh, we're going to carry on like usual. Or we're going to reduce by 1% compared to business as usual. That might be quite easy to build a coalition around, but it's not going to do any good. Maybe it would be better to have a coalition of 30% of countries which agree to get rid of 30% of their emissions. It's going to make a much bigger difference. So, a lot of the literature on sort of the game theory and climate is about building coalitions. Okay. And it's actually pretty tricky stuff. So we're not going to talk much about that. In the problems, what were the problems, the exercises? Were they about building coalitions? In a way they were, but it depends what you mean by a coalition. How many countries were there in those problems? Two, yeah. But then what do we look at? At the end, you said, okay, what are the net benefits, kind of, to country A and to country B? And then you say, kind of, okay, country in first best, there's a net benefit overall. But if they just implement first best separately without any side payments, you could say, oh, but country one is actually losing and country two is gaining a lot more than country one is losing. But why would country one ever agree to that? So then you'd say, well, country two needs to compensate country one by at least 1,000 crowns a year or 1 million, whatever. Yeah, that's kind of what happened in those problems. In the literature, it's like, okay, let's say we've got 100 countries, and we want to try to find a coalition that will maximize net benefits. A kind of policy suggestion that will maximize the benefits for everybody, and that is actually achievable. If you had no problem with paying each other, then it shouldn't be that big a problem, right? That you should be able to agree on first best, and then the ones with the biggest benefits would pay the ones with the biggest costs. But then you're going to start fighting about, okay, well, we shouldn't have to pay because, and in practice it's like a nightmare. Okay. So that's a bit of context for this game theoretical stuff and all this stuff about who pays. And 1 and 3 here are kind of about who pays. So in first best, we should stop using coal, right? And already in the rich countries, even without climate change, we're stopping using coal. Like the British started winding down their coal use in the 80s. Why was that? Or why in yeah, you don't need to know about 80s British history, but I mean, what is against coal apart from carbon emissions? It's quite important. I mean, it's not that hard. Compare coal to gas, say. It's just natural science, really, but yeah, at not a particularly high level. Like what the Swedes and the Germans were not too keen on the Brits burning coal in the 80s either, even though no one cared that much then about climate change. What were the Swedes getting a bee in their bonnet about in the 80s?
The ship.
Acidification, yeah. Thing is, coal-fired power stations spew out all sorts of pollution. Right. Horrible stuff. Apart from the acid, it's bad enough, but there's also like heavy metals and things that land more locally, and particles of soot you're breathing in, and of course you can try and clean them up, but then everything you have to clean up and remove from the chimney stack is adding to your costs. And pretty soon it's like, look, why don't we just switch to gas? So that's the rich countries. And basically, the reasons for keeping coal going, like why do they still burn coal in Germany?
I think there's, to some extent, this energy autonomy argument given, and also, actually, I don't know, is it also some politics reason that you want to safeguard workers in this sector?
I think it's the sort of the same reason, except the other way around, that Thatcher wanted to wipe out the coal industry in the UK. It's the politics of the jobs. Thatcher hated the coal mining unions, so if she could wipe out the industry, then the unions would disappear. So that was great. Whereas in Germany, they, for some reason, they want to keep coal miners in jobs. I think that's a problem. And then, what's Sveafrön in English? There's this sort of false reasons given as like, oh, we need energy, we want to produce all our energy domestically or whatever. My guess would be that that is mainly a cover for the true motivation. But I'm not an expert on the German energy sector, so that could be bullshit, but... Okay. And the US coal was like disappearing and now it's coming back to some extent. And it's purely political, right? It's just Trump is like wanting to subsidize that industry to show that he's supporting or try to look good supporting downtrodden workers. It's a kind of symbolic thing that, I mean, the actual number of workers is trivial. But it's a big symbol, somehow, the coal industry. Okay, so apart from those sort of special cases, basically the rich world is like coal, no, we don't want this stuff, it's filthy. But the poorer countries, the costs of switching to other stuff is about the same, but their GDP is so much lower, so we'll have the cheapest, thanks, you know. But in first best, globally, everybody should be taking on the same marginal cost, shouldn't they? Which should mean that everybody should be dumping coal. From a climate carbon dioxide point of view, the local pollutants, your differentiated costs, but the carbon dioxide should have the same cost. But if you start telling that to China and India, it's like, well, no, you know, sure, in the future sometime we have this ambition to get rid of coal in 50 years or 100 years. So how could you stop them using coal? So Harstad had this idea. So you've seen the video on this one, but you guys haven't, right? So what was Harstad's idea? It's basically there, the top line there.
Yeah. To buy
Just-
everything at the front or at the benefit.
Yeah. So you basically, Harstad's idea was you just buy up the stocks in the ground, yeah, before they're extracted. And then, so you buy the mineral rights effectively. And then leave it in the ground.
And such suggestions to buy up just the stocks, are they considering also scarcity rents that with increased scarcity that the prices
Yeah.
will go up, or is it just the given price today and the profit margin they have today and to this?
Yeah, no, you have to take that into account. And I kind of when I actually started, I got a bit stuck on that video because it was like, I was thinking it was all very straightforward, and then I wasn't too happy with the analysis actually in the paper, so I ended up changing it.
It was kind of nice when you shifted the marginal costs. I think that is that what it is? I guess,
Yeah. So in the video, so basically the answer is yes, you have to account for that. And in the paper, Harstad says, look, imagine you've got a bunch of countries, and this is kind of for each country, they're all identical. This is just in his quick example, and then he does a load of math for more sophisticated stuff, which we're not going to go through. So this is marginal costs and benefits, isn't it? So this must be dollars per ton, and this is like ton. No, ton. Yeah, and it's like a one-period model, I think, really, you have to interpret this as. I think that's what I did in the video. So, what's this? This is tons extracted, isn't it? So what's this going to be? This must be extraction costs. And this is extraction benefits. Okay, so this is like the value of the electricity. And this is the cost of getting it out of the ground. And then if we've got Nordhaus, you want to add this on. So this is the marginal damage from Nordhaus. So it's Nordhaus because it's just flat, yeah. It's adding the same amount on whatever. So in laissez-faire, if each country just makes its mind up on its own, you do this, but in first best, you'd have this, right? And of course, typically, I should have drawn this one maybe higher up. And then, what coal stocks would you have to buy up to make sure it stays in the ground, well, the price is going to end up here, isn't it? So you need to buy up these stocks, don't you? To make sure that these ones you don't buy up because you're okay with them being extracted. These ones you don't need to buy up because the cost of extraction will still be above the price. And this lot will be left in the ground. So that's the analysis in the paper. But then when you start looking at what this is actually going to cost, I wasn't totally happy with whether this was really making sense. So therefore I decided to switch it and say, look, let's assume that this is this what I did? Or did I have this one coming flat? No.
Oh yeah, no, it was the benefits that
The
was
benefits.
So what you would pay, I guess, for any, since you argued that there were alternative sources of energy, so you would have a
Yeah.
constant price.
Yeah. So I wasn't actually too happy with, when I wanted to go into the details and explain it fully, I wasn't too happy with how it panned out. So therefore I just said, look, let's imagine that the coal sector is one sector among others, and whether or not we extract coal is not going to affect the electricity price or whatever, because there's alternatives. So we just or it's affecting it, but by a fixed amount. The less coal you extract, the more gas you need, and then it's a fixed cost. So again, this is the market, but then if we've got this damage cost, no, hang on.
You didn't have the damage cost in the video, but I guess you would have to shift the extraction cost up, not the...
Yeah, sorry, yeah. I was so focused on this one. So this is benefit. Yeah. And then adding to the extraction cost is damage. So this would be first best, yeah. And this should be left in the ground. And so you're going to have to buy up these stocks, aren't you? And if you take these stocks out of the equation, then the extraction cost curve for this country is going to look like that. Okay, because these ones have just disappeared, so this then shifts back. And then there's a question, okay, how much are you going to have to pay to get these out of the market? Have a think about that. How much would you have to pay to get that lot out of the market? So this is very much linked to your question, right? So if you think of the first unit, if you want to buy a ton of this coal, how much are you going to have to pay? In dollars per ton.
I saw the video.
Yeah. So this is what it costs to extract. This is the benefit you can get out of it, that ton. So you're going to have to pay the difference, aren't you? This This is the value of the stock in the ground per ton at this point. And the value of this ton, which is deeper or trickier to get out, is just that number of dollars, isn't it? And the value of this is nothing. Yeah, this is worthless because it costs more to get it out than the benefit you can get out of it. So that's why you only need to buy up this stuff, and the total cost is going to be that. And the benefit is this whole thing, isn't it? The area under the damage curve. The total damage is avoided. But then what Harstad doesn't really talk about in the simplified example is that this is like the coalition buying the stocks of the non-coalition members. And then the question is, okay, how many people, how many countries can you get to join your coalition and actually do this? I don't know to what extent he tackles that question. I'd have to look at the paper more carefully. But assuming you've got a coalition that, for whatever reason, really wants to do something, they can do stuff at home and stop burning coal at home, can't they? But if they, the second thing they need to do is stop extracting their coal at home. Like stopping burning it is one thing, but if you're still extracting it and selling it on the world market, that's helping keep the price down for others. So that's the second thing, is to leave your own stuff in the ground. And then this is like the third step, is to buy up the stocks of other countries. So then you're not kind of bribing them to agree or whatever, you don't need to negotiate, you're just sort of saying, you can just make it a take or leave it offer for their stocks, and you should, if you have the information, you should be able to find that offer which is equal to that area. So that's Harstad's idea. Okay. Then there's this really interesting stuff on liability, which I guess we'll talk about on Thursday. Yeah, we should stop there because I don't want to start getting into liability now, there's not time. So basically, there's a bit more stuff I want to talk about. Oops. Which will be Thursday, I guess. But apart from that, then, it's going to be based around these other issues which we're going to be tackling through the project, your projects. So, I'm going to stop.